Here's the training objectives on this task. To do welding cap pass with the specified welding process according to the provided drawing for 10T pressure vessel. Task: to weld the cap pass of the 10 mm pressure vessel. Objective: to complete cap pass welding for pressure vessel with the specified welding process. Goals: to strengthen welding skills for the pressure vessel, to make a sound weld without any welding defects such as undercut, overlap, etc. Materials: for the pressure vessel, use a 10 mm plate, 400 mm in length, 30 mm in width, and 350 mm in height. For welding rods, KH500LF, KC28, K71T, and T50 are used according to the welding technique. Main focus of the task. For cap pass welding, consider the weld profile. It's important to make a bead profile to fit the marking standard. When welding starts, beads connection. Grind off beads for a smooth transition. When tack welds are cracked, confirm the welding sequence and keep welding in order. It is important to cover the start and end point with following pass welding, since welding defects easily present at these points. For SMAW process, dry welding electrode completely to prevent absorbing moisture. Remove spatter immediately whenever welding finished to prevent creating an obstacle. When weaving the beads, it is necessary to hold the torch and the welding rod well, and weaving so that the slag can be easily removed. For cap pass, deposit welding bead up to marked line is critical. Check the marking line clearly and pay attention to deposit welding beads. Please check the preparations and tools for this training. Precautions. When working on a pressure vessel, it is possible to rotate the vessel based on the base plate. But turning over the vessel is not allowed. The corner joint where welding beads intersect shall have specified R value. Grind off properly to make smoothly bead transition. Work carefully to ensure that the bead height and bead width of the cap pass come out uniformly. The difference between the highest bead height and the lowest bead height should not be more than 2 mm. For T-fillet welding, fillet size shall be kept 10 to 12 mm. Check the marked guideline and deposit welding bead fully up to the marked line. When welding finished, overlap, undercut, and porosity shall not be observed. Please check the tasks to perform. Butt joint welding. Horizontal butt joint welding. Weld first cap pass with the FCAW process 136. The cap pass of horizontal welding is usually stacked 3 times in total as first, second, and third. For first cap pass, weld straightly align with the bottom groove edge. When first cap pass welding is completed, remove slag with a chipping hammer. Grind off the upper part of the first cap pass and keep the line straight. Second cap pass of the FCAW butt joint welding. For second cap pass, weld by covering 1/2 or 1/3 of first cap pass. In horizontal welding, weaving is not possible because the welding material flows down. Therefore, in order to make a sufficient bead width to the improved surface, it is necessary to stack the cap pass 3 times. When second cap pass welding is completed, remove slag with a chipping hammer. Grind off the upper part of second cap pass and keep the line straight. Third cap is the last. Cap pass, weld by covering 1/2 or 1/3 of second cap pass. In horizontal welding, the flow of the melt may be different depending on the angle of the welding rod, so pay attention to the angle of progress. When welding is completed, remove slag on beads completely. When the groove width is wider than this joint, weld joint shall be deposited with more welding passes. Vertical butt joint welding. Weld with the GMAW process 135. Remove excessive beads generated while the horizontal welding with a grinder. Vertical welding shall be started from the bottom and proceeded to the top. Check the bead width that needs to be filled at the first point of view. When the bead width is confirmed, start weaving. Weave in a semicircle or in a zigzag pattern and deposit welding beads up to the end by fusing 0.5 mm groove edge. Avoid incomplete penetration, undercut, and overlap while fusing the groove edge. Welding defect could be generated when travel speed is too fast, present contaminant, or there is a problem with equipment since the GTAW process is extremely sensitive welding process. From 5 mm ahead of the endpoint, keep arc length short and make 2 or 3 spot welds. Corner joint welding. Inclined vertical joint welding. Weld with number 111 SMAW process. Use 3.2 mm electrode and set welding current at 110 ampere. Strike an arc at the bottom part and start weaving when the arc is stabilized. For root pass, triangle weaving technique is used, but for cap pass, side-by-side weaving technique is used. Pay extra attention to prevent any defects for cap pass, which is welding profile to be accessed. Weave the arc from one groove edge to the other by keeping the short arc length. Due to the limited length of the welding electrode for SMAW, stop-starts cannot be avoided. 80 to 100 mm length of welds could be made with one electrode. Remove slag on the welding bead with a chipping hammer whenever one electrode all consumed. For welding stops-starts on cap pass, strike an arc 15 to 20 mm in front of welds. Then, bring it back to the welds and keep weaving. Keep the short arc length to prevent any welding defects. During welding, pause briefly at both ends and travel fast across the center. If the electrode paused too long in the center, it may occur the overlap. Stop welding and remove slag on the welding bead with a spot weld hammer whenever one electrode all consumed. For a stop-start of SMAW process, strike an arc in front of welds, then bring it back to welds making U and connect welds when the arc has stabilized. The bead connection of stops-starts on cap pass should be invisible. Pay attention to prevent excessive face reinforcement such as overlap. Extend welding beads to make endpoint welding invisible and to be covered by corner joint welding. Remove slag on welds with a chipping hammer. Horizontal corner joint welding. Grind off the excessive reinforcement and uneven beads. After grinding works, clean up contaminants with a cup brush. Weld horizontal corner joint with number 111 SMAW process. For first cap pass, weld straight align with groove edge. Keep 95 to 110 degree electrode working angle and weld with stringer bead without weaving by making round shape beads. When joint welding the horizontal corner, there is a part where the vertical butt welded bead meets. This part is difficult to make a straight bead, so you have to pass it a little slowly and weld it. When first cap pass welding is completed, remove slag with a chipping hammer. The horizontal corner joint welding is a second cap pass welding. Keep the welding work angle 85 to 90 degrees lower than first cap pass and weld up to the highest bead. For second cap pass, weld by covering 1/2 or 1/3 of first cap pass and up to 1 mm ahead from the upper groove edge. Be careful not to melt the line above the improvement surface as it becomes the baseline of the last third cap pass. For second cap pass welding, weld with stringer bead without weaving by making round shape beads. Grind off the excessive reinforcement and uneven beads. This is the third cap pass of horizontal corner joint. Start by gently touching the welding rod at the start point and using the arc. And when the welding material is stable, proceed slowly as soon as the welding rod melts without weaving. Weld by fusing 1 mm of the upper groove edge and keep uniform volume of molten metal. Keep your eyes on tip of welding electrode as the electrode would have the eccentricity while melting. Finalize it by extending beads so that an end point can be covered by the following welding. Remove slag with a spot weld hammer. For horizontal welding, welding beads shall have a profile like a knife line. Fillet welding. Inclined vertical fillet welding. Welding with number 136 FCAW process. Deposit welding beads up to the marked line by weaving. Progress welding with the weaving technique without undercut while checking 10 mm fillet guide line at both sides. For the FCAW fillet welding, a thin root pass made in order to keep a travel speed for cap pass slow, unlike the other passes. Slow travel speed is convenient to keep the required fillet size aligned with the marked line. After welding, remove slag with a spot weld hammer. Pipe joint welding. For pipe joint fillet welding, weld with number 111 SMAW process. Fillet size for pipe joint is 8 mm, and it includes all-around welding. The cap pass is piled up a total of 2 times. Weld first cap pass along with the bottom guideline. Remove slag with a spot weld hammer. This is the second cap pass of pipe joint welding. For first cap pass, the electrode work angle moves up and down, starting from the top. For second cap pass, hold the electrode work angle slightly up from the horizontal level as welding progresses as per the line above the guideline. Weld second cap pass along with the guideline drawn on the pipe. When the size of keyhole and molten puddle is fit with marked guideline, make a stringer bead without weaving. Remove slag with a spot weld hammer. For pipe mild steel corner welding, weld with number 141 GTAW process. Weld up to groove edge by weaving. Weave and travel forward in a half moon or in a zigzag pattern. Keep the tilting angle of the filler metal to the weld line at 10 to 20 degrees. Make weld by pushing torch toward where the arc starts. When filler metal is fed uniformly, a filler metal will remain on the bead the same as this point. Pipe joint butt welding. Weld horizontal butt joints with number 141 GTAW process. Welding bead should be deposited uniformly for the horizontal butt welding. To keep uniform bead width, weaving width should be kept uniformly. Weaving along with the pipe radius by keeping uniform arc length. Welding condition check. Check the completed pressure vessel. Check if it is welded with the specified welding process and any discrepancy between the actual and the drawing. Check if the weld widths are uniform and regular and all stop-starts on the capping layer are connected smoothly. Check if the weld have a smooth radius and filled up completely. The R value of the corner should be 10R. Also, check whether the R value came out correctly. Check if the fillet joint weld metal completely fused into the base material and between the individual runs. Please check the key points of the tasks you have done this time.
체크해보세요.
So far, we have looked at the construction of the cap pass of the pressure vessel. Thank you for your hard work.